the sun has like this 7-year cycle or 14-year cycle, depending on how you want to look at it. And it gets active and it gets inactive and it gets active and it gets inactive. And when it gets active, it puts out a lot more radiation at certain wavelengths. And they don't matter so much to us down here, hard to detect on the surface of the Earth. But in the very upper atmosphere, solar activity, particularly solar flares, those solar excursions make big changes in the extreme upper atmospheric density. They can change the temperature of the upper atmosphere and hence the density. They puff up the atmosphere of the Earth, and it gets way denser at like 200, 300, 400, 500 kilometers even above the surface of the Earth when the sun gets active. And that makes stuff get dragged down much faster, because if there's more atmospheric density, it gets slowed down, and then it slows down more, and then it gets denser in the lower atmosphere, and it burns up. This is the solar cycle, and the debris re-entries kind of superposed with each other. So when the sun is active, the red curve, more debris re-enters. So that's, there's some cleaning that's going on naturally, but not enough. So another thing we do is we restrict the lifetime of satellites. And meaning, so we don't want a bunch of dead satellites up there. There are already too many, and we really don't want dead satellites up there. So what does that mean? Well, you can never ensure that a satellite won't die and just remain in orbit as basically a big piece of junk. But what you can do is you can say you have to dispose of it after a certain number of years if it's still alive. So you have to have an engine on it with enough propellant to take it and re-enter into the Earth's atmosphere, or at the very least, put it into an orbit that nobody cares about. So those are disposal options. Another thing you can do is just fly it very low to begin with, and then you know it's going to have a very short lifetime, even if it dies. That's what we do at Planet Labs mostly, is we build satellites and we launch them into relatively low orbits. They're only designed to last, say, 5 years, because after 5 years, the technology is presumably much better, and we don't really want them anymore, so we just have them at a low enough orbit that after about 5 years, they re-enter and burn up. But that's not always been the case. If you're building a $1 billion satellite, you might want it to last a lot longer than 5 years. And therefore, you have to be very careful and have some way to dispose of it. And unfortunately, the world's largest piece of space junk right now is a $1 billion satellite called ENVISAT that the European Space Agency sent up there. It's about the size of a school bus, and it died. And it's totally dead. I mean, it's up there. And these very large dead objects are, in a sense, the biggest threat, because if something collides with them, they can make a huge mess. There's a lot of proposals also for going up and getting stuff out of orbit. That's called active debris removal. So the first thing that you do to sort of avoid collisions, at least for active satellites, is have a traffic management system, kind of like we do with air traffic management. And you want the satellites you want everybody to know where all the satellites are, and you want everything in an orderly pattern so that collisions are very unlikely. This would be a typical distribution of satellites in a big constellation, like maybe Starlink or OneWeb or something like that. I mean, this is simplified, but a lot of satellites in a lot of different orbits. And it might look like a giant mess, and how could you how could you hope to not have a collision with a constellation this dense? But the issue is that if you look at it in a three-dimensional geometry, you can see that there's ways to kind of thread stuff through each other. You can imagine this thing sort of fully populated with these orange dots, like there could be thousands and thousands of them up there, and if they're all choreographed just right, they can sort of do a dance. And one way to understand the dance is to map it out in other coordinate systems, so that like instead of latitude and longitude on the Earth, you can kind of map it out in these grids or in toruses where you're using different mathematical functions. And then they turn into these regular square patterns. And in a sense, every satellite is just sitting in a box. Now, when you put it back onto the 3 dimensions of the sphere of the Earth, it doesn't look like a box so much anymore. So here's the Starlink constellation. And we're mapping it out not in latitude and longitude, or not in altitude and inclination, or any of the standard orbital elements. And what we see here is a bunch of Starlink satellites. And the ones that are in their assigned orbits are these pale gray dots. And then the brightly colored ones are the ones that have been recently launched. So the ones that have recently been launched are the ones that are moving. And once they get into their assigned positions, they turn gray. Each different launch is a different color. And you can see as they get gray, they just drop onto this grid. And this means that even though they're all in orbit around the Earth in this complicated dance, in this special coordinate system, they're just lying on a grid. The diamond-shaped ones are defunct. Some of those defunct ones, they're really defunct, like they have no control over them anymore. But the point is that you can see these gray ones on the right slowing down, and now they're locked into their position, and now we're going to watch these blue ones. They slow down and they lock into their position and turn gray. And you can see that they're slowly building up this grid. And then when you have this grid, if everybody stays in their box, once it's just a rigid grid, and they're all up there, and everybody stays in their little box, there's not going to be any collisions in that constellation. And so we could have boxes like that globally, for the entire world's satellites, actually, and we can have lots of satellites up there if everybody stays in their box. And of course, this is complicated by the fact that you've got debris objects streaming through here who don't know about the boxes, right? But it's a start. So what do we do about these debris objects? So we can do active debris removal. Everybody's got their favorite idea. Oh, we're going to build a robot with claws, and it's going to grab stuff and then bring it back to Earth. Or we're going to this is an actual satellite servicing mission, but satellite servicing and debris removal are very similar. You have to get into proximity of another satellite. You have to grab it. You have to attach to it, and then you have to do something, either refuel it or bring it or bring it back to the atmosphere so it can burn up, or move it to some graveyard orbit. But this is very similar to what you'd have to do if you were trying to bring a dead satellite back. Now, the problem is oftentimes debris objects and dead objects, they're tumbling. It makes it harder to get a hold of them. So, of course, people have said, oh, well, we'll just inflate like giant balloons, and we'll somehow stick it to a balloon, or everyone thinks they're very clever. Why don't you just send up a net? And the thing to remember about this is these are objects in orbit, and if you do this, if you get something wrong, you end up just creating more debris. Like, you can imagine this net gets tangled up, and then now you've got an even worse problem, right? And now you've got an even bigger thing flying around there, or something accidentally, it gets tangled up and it hits something else. And also, by the way, all these kind of schemes like this, they also are like anti-satellite weapons in disguise, because I could just as well use this to go take your satellite and remove it, or to cover it up or turn it off, as I could to take a piece of space junk out of orbit. I don't know where people come up with these ideas, but I just collected as many as I could. We're going to catch it with harpoons, and then drag it away. Now, this was a European space mission that got pretty far along the planning phase, called E.D Orbit. This thing on the right is that school bus-sized, gigantic ENVISAT dead environmental satellite, and then the thing on the left was fully all designed and ready to go. Well, it wasn't built yet, and it was going to grab the ENVISAT, which was not tumbling, I don't believe, and attach itself to the ENVISAT, and then just deboost the whole thing down into the atmosphere. And that got canceled, unfortunately. So that's ENVISAT is still up there. But they are actually this is going to launch in 2025. This is called Clear Space. The thing on the left is getting this medium-sized piece of junk that's known to be up there. And Europe is spending 86 million euros on this mission to bring back this one piece of junk.